Hello friends, welcome back to Edupedia Word videos. Let us study usage of similarity criteria of triangles. Friends, we have studied that there are three simple criteria to prove that the given pair is a similar triangle. The criteria are triple S criteria, which says that if all the three corresponding sides are proportional, then the two triangles are similar. The second is SAS criteria, which says that two corresponding sides to be proportional and one corresponding angles in both the triangles, the given pair, to be equal, then the given pair of triangles is similar. And the third criteria is double A criteria, or you can say triple A criteria. This criteria says that if three angles or two angles in a given pair of triangle are equal, then the given triangles are similar. We have used two angles because of the interior sum angle property of the triangles, which says that if two angles are equal, the third angle will be automatically equal for the sum of the interior three angles to be equal to 180 degree. Now let us study some questions. The first question says, check if the given pair is similar or not. Friends, first of all, let us see if these are similar, by which criteria we can prove that these two triangles are similar. Clearly we are given sides. That is, in the first case we are given 4, 4.5 and 5, the length of the sides in units when written in ascending order. Similarly, if we write here in ascending order, the sides are 8, 9 and 10. So there is no mention about the angles of the triangles. Thus we can use only triple S criteria to prove the given triangles to be similar. If we look clearly, 4 multiplied by 2 will give 8, 4.5 multiplied by 2 will give 9, and 5 multiplied by 2 will give 10. Thus, we have an arranged corresponding sides. The side corresponding to 4 is MN, corresponding to 4.5 is NO, and corresponding to 5 is MO. And here 8 is the side TV, 9 is the side UV, and 10 is the side TU. Thus, what is MN over TV? It is 4 over 8, which is 1 by 2. And what is NO over UV? It is 4.5 over 9, which is again 1 by 2. Similarly, MO over TU is 5 over 10, which is again 1 by 2. Thus we can say that all the three corresponding sides are proportional. That is, MN is corresponding to TV and the ratio is proportional to NO over UV, and this ratio is again proportional as MO over TU. Now regarding the order in which the triangles are similar, if we look here, M is corresponding to T and N with V. Now since N is corresponding to V, therefore O is corresponding to U, because in both the cases when O is occurring, then in denominator we have U. Thus we can say M is corresponding to T, O is corresponding to U, and N is corresponding to V. Thus triangle MON is similar to triangle TUV. Moreover, you cannot say that MNO is similar to triangle TUV, because here it will mean that MN is corresponding to TU. Now MN is 4 units and TU is 10 units. the ratio will not be 2. Thus there is a specific order in which you can write that the given triangles are similar, and by practice you can write this order. Now let us have another question. The question says we are given a figure and we need to prove these 4 conditions. Friends, let us pick up the first case, that is triangle PTO and triangle RSO. Let us first locate the 2 triangles. Here this is the triangle PTO and here it is the triangle RSO. Since we need to prove that these 2 triangles are similar, and in the previous question we have learned that there is a specific order in which we can prove the triangles to be similar. If PTO is similar to RSO, we cannot say that POT is also similar to RSO or ROS. So if we need to prove these 2 triangles to be similar, we need to correspond P with R, T with S and O with O. Now the angle formed by O in PTO is this angle, let it be 1, and the angle formed by O in RSO is this angle, that is angle 2. So you can also see that if 2 vertices are given same in the 2 triangles, it does not necessarily mean that the angle formed will also be same in both the cases. But here we can say that angle 1 is equal to angle 2 because both are vertically opposite angles, and vertically opposite angles are always same. Now there is no information about P and R, but see, QR is a line and PS is perpendicular to it. For a line, the complete angle is 180 degree. So if this angle is 90 degree, then this angle X plus 90 degree will be 180 degree. So angle X will also become 180 degree minus 90 degree, which will be 90 degree. So we can say that this angle is also 90 degree. Similarly here, this angle is also 90 degree. So in triangle PTO, this angle 3, and in triangle RSO, this angle 4 is also same, is also equal, because both are 90 degree. Since the 2 angles are same, the third angle will also be same because of the interior sum angle property of a triangle, which says that sum of all the interior angles of a triangle will be equal to 180 degree. So by AA criteria, we can say that triangle PTO is similar to triangle RSO. Let us move on to the next question. In this case, we need to prove that triangle PQS is similar to triangle RQT. So the corresponding vertices will be P will correspond to R, Q with Q and S with T. Now let us locate these 2 triangles, P, Q and S is this triangle, and R, Q and T is the second triangle. Now if we look at the angle Q in both the cases, it is same angle for both the triangles, unlike the previous case where O vertices describe 2 different angles. So here we can say that both are common angles, that is angle Q of this triangle is equal to angle Q of another triangle RQT. Now angle S of PQS is 90 degree, and similarly angle RQT is also 90 degree. Thus angle S is equal to angle T, that is 90 degree each. So by AA criteria, we can again say that triangle PQS is similar to triangle RQT. Let us prove the third part, that is in triangle OSR and triangle QTR. So to prove these two, we need to prove that O is corresponding to Q, S is corresponding to T, and R with R. Let us locate these two triangles. OSR. OSR is this triangle, and QTR is this bigger triangle. So in the smaller OSR and the giant QTR, if we look clearly, R is common to both. So we can say that angle R is equal to angle R because it is common in both the triangles. And for vertices S and T, S of OSR and T of QTR are both 90 degree each. So thus we can say that triangle OSR is similar to triangle QTR by AA criteria. Now the last part of this problem, PTO and PSQ. So the corresponding vertices are P, T, S, O. Friends, why we are writing these corresponding vertices? Because then the analysis become easy for the two triangles. That is what we have to prove, which vertices we have to prove corresponding to which vertices. So for PTO, this is the triangle PTO and the triangle PSQ, that is PTO and PSQ. We can see that angle P are common in both the cases, and T and S, PTO and PSQ, yes, angle T is equal to angle S, that is 90 degree in both the cases. So by AA criteria, again we can say that triangle PTO is similar to triangle PSQ. The third question says, prove that ratio of medians of similar triangles is equal to the ratio of corresponding sides of two triangles. Let us first sort out what is given in this question. We are given two similar triangles. Let these triangles be PQR and TUV. And we need to prove somewhat on ratio of medians. So first of all, we need to construct medians. Friend, median is a straight line drawn with the purpose of bisecting one of the side from one of the vertex. That is, if we draw a straight line from P such that it bisects QR, then it will be the median of QR from P. So in both the triangles, let the medians be PD and TM. We need to prove that PD over TM, their ratio is equal to the ratio of corresponding sides of similar triangles. Now the corresponding sides are PQ is corresponding to TU and QR to UV and PR to TV. So let us prove this question. Friends, first of all, since PD and TM are medians of QR and UV respectively, so in triangle PQR, QD is equal to DR is equal to half of QR because of PD being the median. Or we can say that QR is equal to twice of QD. Similarly, by the same calculations, we can say that UV is twice of UN. The complete side is twice of the half of itself, because Tm is the median of UV from T. Now friends, if we'll look at this given condition, that is, since triangle PQR is similar to triangle TUV, therefore the corresponding angles will be equal. Q with U and R with V. Also, the ratio of corresponding sides, that is PQ over TU, is equal to QR over UV is equal to PR over TV. Now from 1 and 2 we can say that QR is twice of QD and UV is twice of UM. So in place of QR ratio UV we can also substitute this ratio, or we can say that it is nothing but QD over UM, because 2 gets cancelled by 2. So QD and UM and these two corresponding sides, if we look, are in these two triangles. So let us check about PQ and TU. Thus we can say that PQ over TU is equal to QD over UM, that is PQ is corresponding to TU and QD with UM. And also from here we can say that angle Q is equal to angle U. So by SAS criteria we can say that these two triangles are similar, that is triangle PQD is similar to triangle TUM. Since these two triangles are similar, their corresponding sides will be proportional, that is PQ over TU is equal to QD over UM is equal to PD over TM. From here, this conclusion was already drawn here, but the new conclusion is that PQ over TU is equal to PD over TM. PD and TM are, my dear friends, medians. Now since they are equal to PQ and TU, so these two will also be equal to PQ over TU. Hence we can write as thus we can say that PD over TM, the ratio of medians, are equal to the ratio of corresponding sides PQ, TU, QR, UV and PR, TV. Hence the ratio of medians of similar triangles are in the ratio of corresponding sides of two triangles. So friends, these were some questions on similarity criteria in two similar triangles. Thanks friends for watching this video.